Alright, in this video I want to investigate the angles formed from two parallel lines cut by a transversal, and I want to identify the congruent angle pairs, the supplementary angle pairs, and I also want to give names for different pairs. It'll be useful to give names because it'll allow us to just quickly communicate what pairs we're referring to. Alright, so let me first draw two parallel lines, and let's make a transversal that cuts both of those. And so the angles are, we'll just give them, maybe they aren't the most creative names in the world, but let's just call them angles 1 through 8. And also I'm going to label different regions of the picture. So the region between the two parallel lines, I'm going to refer to that as the interior region. It's interior to both parallel lines. And both regions that are not part of the interior region of the plane, I'm going to call that the exterior region. Alright, so let me label both of those parts of the plane the exterior region. Alright, also when we have a pair of angles and one is on one side of the transversal and one is on the other side, we're going to say that they're on alternate sides of the transversal. Okay, so I'm labeling, we have a transversal and we have parallel lines. Okay, I think we've labeled everything. Alright, so the first thing I'm going to claim is the following. Excuse me. I'm going to claim that the alternate interior angle pairs are congruent. Alright, that's a mouthful, so we'll make sure that everybody understands it. Alternate interior angle pairs are congruent. Okay, so that means if you have two angles, and they're on opposite sides of the transversal, and they're both in the interior, so that would imply 4 and 6. So let me draw lines, that curved lines that say that imply they're congruent, and also 3 and 5 fit that description. So let me put two little lines there. Okay, that's how we signify that those are congruent. Okay, now why is that so, or how can we see that 4 and 6 and angles 3 and 5 are congruent? So let's talk about that. All right, so I want to use a symmetry argument. Symmetry means things don't change. All right, let me, in the bottom right, let me do this. Suppose that I had a Z. I drew the letter Z. All right, let's say that the top and bottom line segments of the Z are congruent. Okay, in other words, they're the same length. And let's also say that they're on top of each other, although that doesn't matter. I could have a Z like this. Okay, as long as the top and bottom are congruent and as long as they are parallel. All right, now let's label the angles. So let me call, just like in my picture, I have angle 4 and 6 in the corresponding positions. Let me call this 4 and angle 6. Angle 4 and angle 6. Now what I'd like you to do is I'd like you to imagine rotating the letter Z 180 degrees, either clockwise or counterclockwise. It doesn't matter. Okay, if you did that, then you would have, well, the Z would be flipped, but now angle 6 would be up here and angle 4 would be down here, right? Likewise, for the other goofy looking Z, you'd have a similar situation. You rotate it, now angle 6 is up there and 4 is down there. Okay? Because the Z doesn't change, in other words, it's symmetrical. If you flip it, the Z looks exactly the same, right? Now, because of that says that angle 4 and angle 6 are congruent. right? Because if I put angle 4 and angle 6 on top of each other, which I can do if I put the blue and the orange Z's, they're going to have the same size opening, all right, if the vertices are lined up. So symmetry is a great argument to see that 4 and 6 are congruent. Okay, so that's my explanation of why alternate interior angle pairs are congruent. Okay, now, and then you can do a similar argument for 3 and 5, or you don't even have to do that. If you know that 4 and 6 are congruent, that's good enough. Watch this. Pick any angle, pick any size you like for 4 and 6. For example, let's call those 40 degrees. Okay, it could be 1 degree, it could be anything. It doesn't matter. You'll get the same result. Watch this. Now, can you see that 3 and 4 are a supplementary angle pair? 3 and 4 together add up to a straight angle. Okay, so that means that they add up to a 180 degree angle. So that forces angle 3 to be 140 degrees. For the same reason, angle 5 is 140 degrees. And so that's another way to see that 3 and 5 are congruent. Right? All right. Now, we also know that vertical angles are congruent. Those are opposite angles when you draw the letter X. So that shows us that angle 2 has to also be 40 degrees. But we already knew that because angle 2 and 3 together add up to a straight angle. So even if you didn't know that vertical angles are always congruent, we just basically proved it again. Okay, and then likewise at the bottom, we know that angle 7 is 140 degrees and angle 8 has to be 40 degrees. So we've got a lot of things congruent and supplementary. Okay, so what I'm going to do now is I'm going to give names to the other pairs of angles that I have, which I haven't named yet. All right, so 1 and 6, or excuse me, let's start with 1 and 7. 1 and 7 are on opposite sides of the on alternate sides of the transversal, but they're in the exterior region, aren't they? Okay, those are congruent, so we'll say that the alternate exterior angle pairs are congruent. Okay, and just in case you missed it, the alternate, well, let me give examples of each of these. So the interior angle pairs are 4 and 6, and then also 3 and 5. Okay, and then the alternate exterior angle pairs, that would be 1 and 7, and the other one would be 2 and 8. All right, so we have alternate interior angles parallel and alternate exterior angle pairs. Excuse me, alternate interior angles are congruent and alternate interior angles are also congruent. Okay, now notice that 2 and 6 are also congruent, as well as 1 and 8 and 3 and 7 and 1 and 5 and 4 and 8, 2 and 6 and 3 and 7. All right, so those, what do we have? Let's give a name for those. So those, we can't call those alternate because they're both on the same side of the transversal. So we'll need another name. We're going to refer to those as corresponding angles. All right, and I'll put that at the top. The corresponding angle pairs are congruent. Okay, and what are the corresponding angle pairs? So 2 and 6. All right, also 4 and 8. Okay, etc., etc. Basically, on the same side, one of them is interior and one of them is exterior. Okay. All right, and let's see. Do we have any other? We've got alternate interior, alternate exterior, corresponding angle pairs. Yeah, those are the most important ones for you to remember. All right. Okay. Also, notice we've got pairs that are supplementary. Okay, 3 and 6, 3 and 4, 3 and 2. All right, 5 and 6, 5 and 7, 5 and 8. All right, etc., etc. All right, the ones that form straight angles. Okay, as well as but they don't have to be right. They don't have to be adjacent. You can 3 and 6 aren't adjacent, but they're still a supplementary angle pair. Okay, now this is looks like a mountain of stuff. One time I was studying for the SAT, or excuse me, I was looking through some material when I was preparing to a class to teach to prepare students for the SAT, and one of the books summarized all of this information in a really compact way, and I just thought it was really cool. I want to share that with you. Would you like an easy way to remember all this stuff? Okay. Notice that there's only 2 sizes of angles in my picture. I've labeled one of them, one of the sizes 40, another one 140. You can pick pick any one angle to be whatever size you want. You'll notice that it'll immediately set the other 7 angles. All right, but the point I'm trying to make is you will always only have 2 sizes for all the 8 angles. You'll only see 2 different measures. Okay, that's the first interesting observation. Okay, also notice that the biggest angle, whatever it is, in this case it's the 140 size, the big angles are always supplementary with the small angles. Okay, and vice versa. Also, all the small angles are congruent and all the big angles are congruent. Okay, that's a very nice clean way to compress all of this information. Okay, to make it easy for you to remember. All right. I don't have a good name for 3 and 6, so let me just say, for the sake of having to give it some kind of name, we'll call them same side interior. Okay, so how about if we say the same side interior angles are supplementary, right? They add up to 180. Also, you could say that the same side exterior angles are supplementary because they are. Okay, and so that's all the information that you're responsible for. All right.